This is A.K. Singh from University of Lucknow, India. The title of my talk is Predictions for Solar Cycles 25th and 26th, a substantial weakening trend in solar activity. So as the title suggests, I have forecasted for the solar activity during solar cycles 25th and 26th. So when we talk about the solar activity, observations and indices can make the decision for the same. So most of the solar indices are highly correlated to each other due to dominant 11-year cycle, but many differ in fine details and long-term trends. Solar activity indices can be either direct, that is directly relating to the sun, or indirect, that is relating to the indirect effects caused by solar activity. Some important solar indices are the sunspot numbers, the F10.7 index, Lyman alpha index, proton flux, magnesium 2 index, solar magnetic field, Alfman Mach number, geomagnetic indices, cosmogenic nuclides like 10 beryllium and carbon 14. If we talk about the most recent solar cycle, so the solar cycle 24th was the most recent solar cycle, which was begun in 2008 and with a smooth minimum sunspot number of 2.2 and ended in December 2019. It reached its maximum in April 2014 with a 23rd month smooth sunspot number of 81.8. Here we can see the solar maximum and solar minimum. In the recent past, this maximum value was substantially lower than other recent solar cycles, down to level which had not been seen since cycles 12 to 23. For forecasting of the solar activities, it has the greater importance because of the scientific as well as social concern. So the best representation of solar activity is the variation in the solar parameters on the time scale. We have analyzed the earlier data of the various solar indices. In this case, we have analyzed sunspot numbers, F10.7 index, and Lyman alpha solar index. And we have predicted the activities, that is solar activities, for the solar cycle 25th and 26th. Here in the figure, we can show that this figure actually shows the variation of solar cycle since cycle 18 to recently observed solar cycle 24. To that end, we have used the Hurst exponent H. Actually, we have obtained the Hurst exponent, which is used as a tool that can give a quantitative measurement of the persistence of a time series. Actually, for obtaining the Hurst exponent, we have used some filtering, that is Hardick and Prescott's filter, to detrend the data which gives the trend component and cyclical component. If you see this figure, this is the original data set, then we have put there the Hardick Prescott filter, and after this filter we have got that cyclical component and the trend component. So we have adopted a sequential application of three major statistical methods on time series of solar parameters, and that is Hardick Prescott filter, which is used for the detrending of time series of solar activity parameters, then the rescale range analysis used in order to search for the persistence in the time series of solar activity measurement, And after that, the simplex projection method is applied for calculation of future projections of solar parameters for the cycle 25th and 26th. So Horst exponent is obtained after the retrending. Horst exponent for sunspot number, it comes out to be this H is nearly this 0.90, and then for F10.7 index it is 0.93, and for H Lyman alpha it is 0.96. So all values of each selected parameters were very close to 1. So it simply implied that these parameters had showed more persistence and carried a memory of all preceded events. Here, this is the data observed, and then we have applied the above procedures on this data. What we got, that this is the trend cycle for this is the trend cyclic components for sunspot number, then F10.7 index and Lyman alpha index, and the trend component for all these parameters. So this is actually the monthly variation of sunspot numbers, 10 F10.7 centimeter index and Lyman alpha index, and this is the observed and predicted. This data, the dotted lines, these lines have shown the predicted values for the sunspot numbers and for F10.7 index and for Lyman alpha index. So what we have seen here, that we have observed the declining trend of solar activity. If we see the comparison, the sunspot numbers since 1700, what we get, that for the solar cycle 25th and 26th, this is solar activity is decreasing in comparison to the earlier solar cycles. Here one more thing we have pointed out, that that is the minima which is going to be happen, it's different than the Dalton minima, because this Dalton minimum was in between the higher solar cycles, or the solar cycles having the higher activity. But here in the present minima, we have got this a trend of decreasing solar activities since past few solar cycles. And if we talk about the particulars of the solar cycle 25, then this cycle, which is already started in the month of January of this year, and would last till the year 2031 February, and the maxima of the cycle would reach around the year 2024 to 2025, with the sunspot numbers 89 plus minus 09. And about solar cycle 26, the cycle will start in March 2031 and will last till February 2043, and the maxima will reach during the year 2036 June, with the particular values of the sunspot numbers around 78 plus minus 7. So what we can see here, that we are definitely getting a decreasing trend in the solar activity for the coming solar cycles. And if we compare this some more predicted values, so what we see from this figure, by 2050 the solar activity will be minimum, and we have predicted for the up to 2043. So our results is very much incomparable to these results, which again shows the indication of a present minima, and this was also named as AD minima. So we can conclude that we are certainly heading towards other minima, and it very much comparable to Dalton minima, that is solar cycle 5th and 6th, but differs in the nature, because Dalton minima was observed in between two high solar active cycles between 4 and 7, while the present minima will followed by a continuous decreasing solar activity trend. So thank you very much.